let's look at some interesting questions on sort. Now, number one, here, let's solve 3 minus 2 root 2 divided by 3 plus 2 root 2. From here, we are going to rationalize the surd here, and we multiply and also divide by the conjugate surd, which implies here the conjugate surd of the denominator, we use it to multiply the numerator and also use it to multiply the denominator. That is, this becomes 3 minus 2 root 2, then multiply by the conjugate surd there. Excuse me, please. The conjugate surd there is also 3 minus 2 root 2. It's only the sign that will change here. Then divided by, in the same way, we multiply this by the same thing, which is 3 plus 2 root 2. Then multiply by also 3 minus 2 root 2. That is, from what we have now, excuse me, please. Here, from above here, what is here? We have same thing inside the bracket. So it's similar to when we have a times a. And when we have a times a, that's same thing as a squared. That is, here we can write this as 3 minus 2 root 2 all squared now, then divided by, from these two brackets, it follows when we have difference of two square in form of a plus b into bracket, then open bracket, a minus b, which here we can write as a squared minus b squared. That is, from here, we have 3 squared, then minus 2 root 2 all squared. Then, solving this further here, also we can expand it. When we apply this expansion of bracket, a minus b all squared, here when we expand this, this becomes a squared plus b squared minus 2ab. That is, from here, this becomes 3 squared plus 2 root 2 all squared, then minus 2 times 3 times 2 root 2 here, which is divided by, here 3 squared becomes 9, then minus, here this square affects 2 and root 2. So 2 squared, that's 4, then times root 2 squared, square cancels square root, and that's simply 2. And here, this is same thing as 3 square here, also we have 9, then plus. The square also affects these two terms, that is 2 squared, that's 4, then times root 2 squared, that's also 2 there, then minus 2 times 3 times 2, 2 times 3, 6 times 2, 12, that's minus 12 root 2 here, which is divided by 9 minus 4 times 2 here, that's 8. Excuse me, please. Then here, also we have 9 plus 4 times 2, that's 8, then minus 12 root 2 here, then over 9 minus 8, that's 1. Then this is 9 plus 8, we have 17 minus 12 root 2, then over 1. So simply here, this is the final answer. 17 minus 12 root 2 is the final answer to this sort. Thank you. And this is Master T. Thank you for watching us here. Don't forget to give a thumbs up and also subscribe for more videos. Now let's look at another question from here. We call this number 2 question here. That is solving another one on sort. So here we have 2 root 5. Let's call this number 2. 2 root 5 minus 7 root 2 divided by 3 root 7 minus 2 root 3. Now from here also we rationalize this surd. And the method of rationalizing the surd is we multiply by the conjugate surd. Multiply both terms here by the conjugate surd of the denominator. So here we have 2 root 5 minus 7 root 2, then multiply by the conjugate surd here is only the sign that will change. So we have 3 root 7 plus 2 root 3 here. Then also we multiply the same thing here by the conjugate surd. That is 3 root 7 minus 2 root 3. Then multiply by also 3 root 7 plus 2 root 3. Now next thing is to expand this bracket. So from here, we use 2 root 5 to multiply these two terms first. So we can say 2 times 3, that's 6. Then root 5 times root 7, that gives us root 35. That's 6 root 35 here. Then 2 root 5 times 2 root 3 here, that gives us plus. We can say 2 times 2, that's 4. Then root 5 times root 3, that gives us root 15. Then also minus 7 root 2, and open this bracket now. That is, we have 7 times, that's minus 7 times 3, that's 21. Then root 2 times 7, that's 10. Then also minus times plus here is still minus. Then 7 times 2, that's 14. Root 2 times root 3, that's root 6 rather. Then divided by, now here this expansion follows when we have a plus b into bracket, open bracket, a minus b, that's perfect square, which we can put as a squared minus b squared. That is, here we have 3 root 7 squared minus 2 root 3 squared. Then when we look at the surd we have here, they're already in their simpler surd, so we can't factor any perfect number out from these ones. So we leave it as here 6 root 35, 10 plus 4 root 15 here, then minus 21 root 10, then minus 14 root 6, which is divided by square will affect 3 here. 3 square, that's 9 times square affect root 7. 7 times 9 times 7, that's, square cancel square root, that's 7, then minus square affect 2 here, that's 4, then times also we have 3. Then solving this further, we have 6 root 35 plus 4 root 15 minus 21 root 10 minus 14 root 6 over 9 times 7, that's 63, then minus 12 here. Then this becomes, so we still have same thing here, no similar surd, we can't add it, we can't subtract. So we have different surd here. So that's 6 root 35 plus 4 root 15 minus 21 root 10 minus 14 root 6, then over 63 minus 12. So 63 minus 12, we have 51 here. Okay, that is, here, this is going to be our final answer from here. Now, let's look at another one. Let's solve another question from here, number 3. So, the next one here, we have 2 minus root 3, then divided by 2 plus root 3, then plus 2 plus root 3, then divided by 2 minus root 3. Now, let's solve this from here. And we have two fractions added together. So the normal way of solving fraction, we can find the LCM here. And when we find the LCM here is the product of these two things. So we bring it together as 2 plus root 3 multiplied by 2 minus root 3. Then, now when this goes in the LCM, that is 2 plus root 3 will cancel out. Then we are left with 2 minus root 3, which we multiply here, which is 2 minus root 3. So we can say this is 2 minus root 3 times 2 minus root 3. We can write it as 2 minus root 3 square. Okay, then plus. Also, 2 minus root 3 goes here. That is 2 minus root 3 cancel with 2 minus root. So we have 2 plus root 3 here. 2 plus root 3 multiplying 2 plus root 3. So we can say this is 2 plus root 3 squared here. That is, from here, when we solve further here, it implies the expansion here, okay, let's start here. The expansion here follows, and we have 2 squared plus root 3 squared, then minus 2 times root 3, 2 times 2 times root 3. So this is the expansion for the first one, then plus. Also, we expand the second one, and we have, this gives us 2 squared plus root 3 squared, then plus 2 times 2 times root 3, which is divided by, here, these are conjugate surd, of course, and we can write this as 2 squared minus root 3 squared. Now, simplifying this now, 2 squared here, that's 4, then plus root 3 squared, that's 3, because square cancels square roots. Then minus 2 times 2, that's 4, then root 3 here, then plus 2 squared, that's also 4 here, then square cancels square roots, we have plus 3, then plus, here we have 4 root 3 here, which is divided by 2 square here, that's 4, then minus square cancel square root, that's 3. And solving this further here, we have 4 plus 3. This gives us 7, then minus 4 root 3, then also plus 7 here, then plus 4 root 3, then over 4 minus 3 here, that's 1. And here, we have 7 plus 7, that's 14. Then minus 4 root 3 plus 4 root 3. This cancel out. So this is 14 over 1, which is simply 14. So that's the solution to this problem here as 14. So that is that. I believe you are enjoying this class. Please share this video, also give it a thumbs up, and also follow us by subscribing. And thank you. Yes, thank you. Now let's look at another one. Also from here, We label this as number 4 here. And this question we have root 5 minus 2 over root 5 plus 2, then plus root 5 plus 2 over root 5 minus 2. Now, also when we solve this, we have two fractions added up here together. So the same way we handle fractions, we can find the SCM. And here the SCM is the product of these two terms. So we have, this will be root 5 plus 2 multiplied by root 5 minus 2. Then, when root 5 plus 2 goes here, it will remain root 5 minus 2. Then root 5 minus 2 will multiply root 5 minus 2. So it's going to be root 5 minus 2 squared now. Then we have plus. Also root 5 minus 2 goes in root 5 minus 2. That is, they cancel each other. We have root 5 plus 2 left. So root 5 plus 2 times root 5 plus 2. You can write that as root 5 plus 2 all squared. Then now, when we expand from here, also, the expansion here becomes root 5 squared plus 2 squared, then minus 2 times root 5 times 2, then also plus the expansion here as well. We have root 5 square, then plus 2 square, plus 2 times root 5 times 2, which is now divided by, what we have here, we have conjugate surd, and we can put it in the form root 5 square minus 2 square. Then, simplifying further now, here, square cancels square root, so we have 5 plus 2 squared, that's 4, then minus 2 times 2, that's 4 root 5 here. Then plus, also here, square cancels square root, that's 5. Then plus, here we have 4 plus 2 times 2 times root 5, that's 4 root 5 from here, which is divided by, here, square also cancels square root. We have 5, then minus 2 squared, that's 4. That is, now next step, we can sum this. 5 plus 4, that's 9, then minus 4 root 5. Then also plus 5 plus 4 here, also 9, then plus 4 root 5. Then over 5 minus 4 here, that's 1. And here, 9 plus 9, so we have 18. Then here, minus 4 root 5 plus 4 root 5 cancelled out. So this is 18 over 1, which is simply same thing as 18. So the solution to this particular solved problem is therefore 18. Now, let's look at another one from here. Don't forget to share this video, like, and subscribe to this channel. So number 5, also on sort, you can also drop your comments. So the next one here, number 5, we have root 3 minus root 2 over root 3 plus root 2, everything raised to power 2. Now, when we have this, we can handle what we have in the bracket first, then we square it. Since you know that square is, it means when things multiply itself, that's square. So when we handle this first, so we have root 3 minus root 2 over root 3 plus root 2. And here, when we rationalize now, this equals to root 3 minus root 2 multiplied by the conjugate surd of the denominator, that's root 3 minus root 2, then divided by, so also here we multiply by the conjugate, that's root 3 plus root 2, now multiply by root 3 minus root 2. Then this here becomes the expansion of, the expansion of here is what we can rewrite as root 3 minus root 2 all squared, since the two brackets are the same. So then divided by, here we have perfect square, that's conjugate, so that's root 3 squared minus root 2 squared. Okay, then here this expansion here becomes root 3 squared plus root 2 squared minus 2 times root 3 times root 2, then divided by, here square cancel square root, that's 3 minus, also same thing here, that's 2. And here this becomes also square cancel square root, that's 3 plus same thing here, cancel each other, that's 2, then minus 2 root 3 times root 2, that gives us root 6, then over 3 minus 2, that's 1. So here now 3 plus 2, that's 5, then minus 2 root 6 over 1. So that is 5 minus 2 root 6. Now because of this square here, so it implies that here we can equally write this as 5 minus 2 root 6 squared. Now when we now solve that, when things multiply itself twice, that's the meaning of square. So then we can double that bracket now, or we can expand like this directly from the identity of when we have a minus b all square. This is the same thing as a square plus b square minus 2ab. Now it implies here now following this, so this will now be 5 square plus 2 root 6 all squared, then minus 2 times 5 times 2 root 6. Okay, so here now 5 square, 5 times 5, that's 25, then plus 2 will affect 2 here, square will affect 2, that's 4, then times root 6 square, that's 6, then minus 2 times 5, that's 10, times 2, that's 20, so we have 20 root 6 here. Then this is equals to 25 plus 4 times 6, that's 24, then minus 20 root 6, and 25 plus 24, here we have 49 minus 20 root 6. So that's simply what we have there as a solution to this particular problem, as 49 minus 20 root 6. And you have been watching us here at Master T Math Class. Don't forget to give us your maximum support, and thank you. Then next, let's look at another one from here. We call this number 6 here. We have root 2 minus 1 over root 2 plus 1 all raised to power 2. Now, in the same way here, when we handle what we have in the bracket, which is root 2 plus minus 1 over root 2 plus 1, so when we rationalize this, here, this becomes root 2 minus 1 times the conjugate of the denominator here is still root 2 minus 1, then divided by, also here multiply this, that's root 2 plus 1, then times root 2 minus 1. Now, what we have up, same thing inside the bracket, so we can write it as root 2 minus 1 all squared, then over here as well. These are conjugate surds, so we have root 2 squared minus 1 squared. And here, the expansion up here becomes root 2 squared plus 1 squared minus 2 times root 2 times 1, which is divided by square cancel square root here, we have 2, then minus 1 squared, that's 1. Then, which implies here, also square cancel square root, that's 2 plus 1 squared, that's 1, then minus 2 times root 2 times 1, that's still 2 root 2, then over 2 minus 1, 1. And here we have 2 plus 1, that's 3, then minus 2 root 2 over 1. So that's 3 minus 2 root 2 there. Okay? Now, it implies what we have here now, we can write it as 3 minus 2 root 2 squared. Now, when we solve this now, from what we have here, the square also can be expanded directly from the identity or square of difference. That is when we have a minus b square. This is a square plus b square minus 2ab, okay? So here we can say this is simply 3 square plus 2 root 2 all squared, then minus 2 times 3 times 2 root 2. Now, adding this from here, we have 3 square, that's 9, then plus square affect 2, and also affect root 2. So that's 4 times 2 here, then minus 2 times 3, that's 6 times 2, that's 12, 12 root 2. So we have this become 9 plus 4 times 2 here, that's 8, then minus 12 root 2. And here we have 17 minus 12 root 2. So the solution to this particular problem is there for this. Thank you for joining us so far. We appreciate you, and don't forget to join us next class. Subscribe not to miss out, and take care. See you next class, and bye for now.